Hi, this is Miss Keys. Today you're going to learn about permutations, and at the end of question number 2 and number 4, a question will pop up on the screen for you to answer, so make sure you're watching the video really close. Alright, number 1. There are 6 ice skaters competing in an ice skating competition. How many different combinations of ice skaters could win the gold, silver, and bronze medal? So since there is a place for each of the ice skaters by winning gold, silver, and bronze, that means that there is going to be an order to this problem, which means this is going to be a permutation. So there's 6 total skaters, and we're going to permutate 3 of them because there's 3 places the ice skaters could win. If you put this in your calculator, you'll end up getting 120. Or we could think of it another way. How many different ice skaters could win the gold medal? 6. And we would multiply that by, now that someone has won the gold medal, how many different people could win the silver medal? 5. And then how many ice skaters could then win the bronze medal? 4. So that would also give us 120. So that means there's 120 different combinations that 6 ice skaters could win the gold, silver, and bronze medal. Number 2, how many different ways are there to arrange the letters in the word star? So when arranging these letters, since the order matters, this again would be a permutation. There's 4 letters in the word star, so we're going to do 4, permutate, and we're arranging all 4 of those letters, so it's going to be 4 permutate 4. If you put that in your calculator, you would get 24, or you could think of 4 permutate 4 as 4 factorial, which is 4 times 3 times 2 times 1, which would also give you 24. So there's 24 different ways that we could rearrange the letters in the word star. Number 3, how many different ways are there to arrange the letters in the word bowls? Now this problem is a little bit different than number 2, because if you look at the word bowls, there's 2 duplicate letters, and that's our 2 L's. So we have 2 L's in this problem, which means when we do different permutations of the word bowls, we're going to have duplicate answers. For example, if I write the word LLUBS, so that would be an example of one of the permutations. It's impossible to tell which L is the first L and which L is the second L. So therefore, there's going to be duplicate permutations. So in order to solve this problem, since there's 5 letters in the word bowls, I'm going to start off doing 5 permutate 5. So I'm going to think of this as a problem where there are no duplicate letters. 5 permutate 5 is the same thing as 5 factorial. Now we need to get rid of our duplicate L's that we have. So I'm going to divide by 2 factorial. Since we have 2 L's, I'm going to divide by 2 factorial. So 5 factorial is 120, and 2 factorial is 2, which is going to give us 60. So that means that there is going to be 60 different ways to rearrange the letters in the word bowls without any duplicate answers. Number 4, Amy is placing different colored chips in a straight line on a table. There are 4 purple, 3 green, 1 red, and 1 blue chip. How many different arrangements can be made with the colored chips? So again, looking at this problem, when we rearrange the chips, we're going to have duplicates again. We have 4 purple chips, and And we also have 3 green chips. And in total, we have 9 total chips. So we're going to have duplicates because we have 4 purple chips and 3 green chips. So when I solve this, I'm going to do 9 permutate 9 as if there weren't any duplicates. And 9 permutate 9 is the same as 9 factorial. Now we need to get rid of our duplicate answers. So we're going to divide out our duplicates. We have 4 purple duplicates, so we're going to divide out 4 factorial, and we're going to multiply that by the number of duplicate green chips, which is 3 factorial. So 9 factorial is going to give us 362,880, and 4 factorial times 3 factorial is 144. This is going to give us 2,520. So there's going to be 2,520 different ways that we can rearrange the colored chips without duplicates.